is Joey, and today I'll be discussing the advancement of prosthetics in the future. So prosthetics are given to people who undergo amputation, and amputation is a common treatment for extreme trauma or disease at the extremities. Prostheses have always been around throughout history, but they're quickly advancing with improving technology. So today I will be discussing prosthetics today, how they can potentially improve in the future, the potential for enhancement, and the ethical implications of enhancements. So first, I'll talk about prosthetics today. So there's three basic models, and those are cosmetic, body-powered, and myoelectric. So cosmetic are just the classical prosthetic you usually see. They function by a simple socket, and they just act to produce the illusion that the individual has not undergone an amputation, and they have no real functional purpose. But they do look pretty realistic, as you can see in these pictures here. But yeah, in terms of allowing you to produce a functional task, they're not really useful. The second is body-powered prosthetics. So basically how these work is there's a hook on the end of the prosthetic, which is attached to a pulley mechanism, and it is harnessed to your torso. And basically how this works is movements at your shoulder and elbow will pull the pulley system to allow the hook to open and close so you can perform some simple functional tasks. The third and arguably the biggest advancement in prosthetics today is the introduction of the myoelectric prosthetic. So basically how these work is they put surface electrodes on your muscles, which read the electrical signals produced by muscle contraction. These signals are then carried over to the prosthetic, and it allows it to produce movements based on which muscle is contracting. So the classical myoelectric prosthetics usually only allow movement on 1 degree of freedom, so they allow for flexion and extension. But these have been improved with the introduction of targeted muscle reinnervation and pattern recognition. So basically what targeted muscle reinnervation is they take the dead nerves from the amputated limb, and they basically reinsert it back into the muscle just proximal to the amputation. And what this allows to do is to create new electrical signals based on the muscle contraction. And these new signals can then be read by the prosthetic to allow for it to produce more movements than the classic myoelectric prosthetic would allow. So basically these allow for it to produce movements along 2 degrees of freedom rather than 1. So all three of these models have their own downsides. Cosmetic, as I discussed, have no real functional purpose, they're just there for looks. Body-powered, while they allow you to do some simple tasks, they're very heavy, uncomfortable, and inconvenient. Myoelectric and pattern recognition and targeted muscle reinnervation, while they allow you to produce movements, they're uncomfortable, they're heavy, they're unintuitive to use. The signal can be disrupted if the prosthetic is not on the amputation correctly, and they can't produce complex sequential movements. And in terms of how sensory integration is being put into prosthetics today, it's actually a very important thing to consider because they found that sensory integration is the most important thing in creating a sense of ownership for the prosthetic. This was found by Collins et al. In 2016. And basically what they did is they had these patients getting ready for surgery for epilepsy, and they inserted these electrodes into the somatosensory cortex of their brain. And they had this plastic arm that they would basically touch a bunch of different objects with, and as they're touching the object, they activated the electrodes in the somatosensory cortex. And basically what this produced is when the activation was in sync with the touching of the arm, it created a sense of ownership. As you can see in this graph here, they rated a high sense of ownership for the limb. So it's important to figure out how they can add these to prosthetics today. There's three ways of kind of considering it. The first one is electrodes, which was the same as that experiment. The second is direct neural stimulation. So basically what they do for this one is they attach electrodes to the end of the sensory nerves, and they directly stimulate them based on inputs from the prosthetic. However, an issue with this is they're not sure of the long-term implications, as direct stimulation like that could potentially cause damage to the tissue over time. And the third one is sensory nerve interfaces. So basically what this is they attach electrodes rather than directly to the sensory nerves. They put it on the surface of the muscle just proximal to amputation, and then based on inputs from the prosthetic, they stimulate that muscle, so it allows to send signals up to the brain without direct stimulation, but again, they don't know the long-term implications of this. So before I get into advancements, I'm going to give some background information on the motor, somatosensory systems, as well as a few neural imaging methods. So the motor system basically works by areas of the brain such as the primary motor cortex, the posterior parietal cortex, the premotor cortex, and the prefrontal cortex, activating to create motor plans, which are then sent down the brainstem and the spinal cord to carry information out to the muscles in the form of action potential sequences. So these brain areas don't only code for individual movements, they can also code for complex end patterns. So this was found by Graziano, Taylor, and Moore. And basically what they did is they put electrodes in the primary motor cortex of monkeys. And when they activated one area specifically, no matter what position the monkey was starting in, it would always end in this position right here, hand to mouth. So basically what this means is that movements aren't only coded as individual, but they can be coded as sequential motor plans. So this has implications in prosthetics because if they can figure out how to read this brain activity for complex end patterns, it would allow them to create smoother moving prosthetics. And the muscles basically receive the action potentials going down the motor nerves, and based on the action potential sequences, it causes a release of calcium, which then binds to the sarcomere of the muscle, which is just the contractile unit, and allows the muscle to contract to produce movement. So the sensory system is a bit more simple. Basically, stimuli in the environment excite sensory receptors in the periphery, which then send signals to sensory nerves to carry to the spinal cord up into the brain. It's processed in a lot of areas of the brain, but mainly the primary somatosensory cortex. And it's actually mapped, so certain areas of the somatosensory cortex will activate under stimulation of different areas of the body. So this has implications for prosthetics because if they can figure out how to send these exact signals up to those specific areas of the brain, they can figure out how to integrate sensory feeling into prosthetics. So functional near-infrared spectroscopy is a brain imaging method. And basically how it works is they shoot near-infrared light in the wavelengths of 650 to 1000 nanometers. And this penetrates the skull and it can go to the brain, in which, based on the patterns of reabsorption and reflection of light, they can basically get an image of what's going on in the brain. Most commonly, this is used to track brain oxygenation, which is basically just the amount of oxygen being carried in the blood to the different areas of the brain, which, similar to fMRI, is a signal of brain activity. So this could be used in brain-computer interfaces, which they've been kind of focusing on a lot, just because near-infrared spectroscopy is very easy to use. And what they found is they've been able to create brain-computer interfaces that allow them to complete cognitive tasks on a remote computer without actually touching it. So if they could figure out a way to add these BCIs into prosthetics, it would allow for greater control without having to physically do anything with it. So I'm going to be talking about two potential mechanisms of how near-infrared spectroscopy could be used with machine learning to allow functional movements at prosthetics. The first one is reinforcement learning. So basically how this would work is the bold signals, which are just the oxygenation signals from the spectroscopy, would be sent to the prosthetic, in which it would react to produce a certain output. And the user would either correct or punish for these movements based on their intention. So over time, with continuous correction, the prosthetic would basically learn what the correct movement for specific patterns of brain activity would be, which would allow it to then produce movements similar to how our organics will do. So the second method is deep learning. And as we learn in class, this is where information is moved through these series of artificial neurons in this neural network. And as information moves through, connections weightings are changed so that at the output, the data that's put through can match what it's supposed to. So it starts off by providing it with some training data, which moves through to correct that weighting, and then new data can be put in to label. So basically then how this would work is after some training data is provided, the prosthetic would learn what certain patterns of brain activity produce certain movements, and then it could read what's going on in our brains and turn that into a motor output. So NearInfrared spectroscopy isn't really useful for sensory integration, but however, one thing they're kind of looking at is the use of optogenetics. So for those of you who don't know, optogenetics is basically where they implant these light-sensitive proteins into the brain, which they can then activate or deactivate under certain wavelengths of light. So right now they're looking at putting these proteins in the ion channels of the sensory nerves, which can then be opened under blue light or closed under red light to depolarize or hyperpolarize the cell. And how machine learning could be used with this is we could then see what patterns of action potentials are necessary for certain sensory feelings in the brain. And these patterns could be sent back to the prosthetic to allow it to basically shine the correct patterns of light. So we could have that action potential sequence being sent up to the brain to allow for sensory feeling of this prosthetic. However, something like this would require close monitoring because unlike motor output, if there's something that goes wrong with our sensory system, the consequences are a lot more serious. For instance, you'd be having intense pain. So it would have to have, the machine learning would require a high degree of confidence before something like this could be integrated with prosthetics. So this is basically just a diagram of how optogenetics works. So you got this light sensor protein, and usually it's added into a virus, and the virus is injected, they've been using this on rats, they inject it into the rat's brain, and the protein becomes integrated into their ion channels, and then they put this fiber optic cable to shine light directly on these proteins to allow it to open the ion channel and sodium to come in. So those are some potential mechanisms of how we could improve prosthetics. Now to ask, is there room for enhancement? So they've already been kind of enhancing prosthetics compared to human limbs today. This video by The Guardian showed these experimenters who basically created this tool that had two drumsticks on one hand, and it allowed the user to control it, and they basically read the muscle contractions using ultrasound. So they could control each of these drumsticks individually. So the guy could play completely new patterns on the drums because he could control these two sticks simultaneously while having a third in his other hand. So basically this has promise of how we could add specific tools to the end of a prosthetic limb to allow for greater control or allow us to do things we couldn't do. So for example, in surgery, we could just attach surgical tools to the end of the prosthetic, which would allow for greater control. We wouldn't have to worry about things like essential tremor, etc. And yeah, you could just be controlling this tool directly with your brain rather than having to hold it with your hand. Another potential enhancement is since prosthetics wouldn't have the same biological restrictions that our organic limbs do, we could see enhancements in strength, power, and endurance. So for example, right now they've been developing these exosuits for soldiers to allow their legs to be more powerful, move faster, hold more weight, etc. But if these exosuits were just prosthetic limbs, we could definitely see a huge enhancement in our physical capabilities. In terms of how sensory could be enhanced, this is kind of more difficult because our sensory systems are adaptive. For example, pain, while it's not pleasant, it warns us of dangers. But there are definitely some situations where we could turn down the pain response in these prosthetics. So for example, when we're holding a hot cup of coffee, we could just turn down that pain sensitivity and not have to worry about wearing things like oven mitts or getting asleep for that or something like that. But again, we'd have to keep in mind that pain is adaptive, and we could definitely find ourselves in some dangerous situations if we're not experiencing pain. So that's something to keep in mind if we're looking at enhancing the sensory system. So now I'm just going to quickly discuss the ethical implications. of advancing prosthetics. The first one I'm going to talk about is the issue of distribution and disparity. So basically this is an issue because prosthetics have kind of been talked about as the next stage in human evolution, but if it's the case that these are, like, this is going to be expensive technology, so if it's the case that you have to purchase it yourself rather than it being distributed evenly, is it going to be the case that only the rich are able to move into this new stage of evolution, leaving the poor not having these prosthetics? In which case that creates not only economic disparity, but also disparity on physical capabilities, which has serious implications for the future. So that's one issue we'd have to consider as we move forward. So the second one I'm going to talk about is sports. Sports are very important in society and culture. It always has been. And prosthetics are already becoming an issue in sports. For example, these two Olympic athletes, Oscar Pistorius and Marcus Rem, are he's a long jump competitor and he's a runner. So they both have these carbon fiber blades to help them compete. However, they had to undergo a lot of competition against using these against non-amputated competitors. Basically because people were saying that these blades allowed them to use less energy, have longer strides, etc. So it's already becoming an issue of people asking whether they're an enhancement on the human body. And not only is this an issue being considered between amputees and non-amputees, but there's also an issue where Pistorius lost a race and basically said his competitor won because he had better carbon fiber blades. So it's kind of something to consider as we move forward, how these are going to work in the realm of sports. Is it going to be that, you know, you're going to have a prosthetic to even compete, or you're going to have to restrict yourself from having an enhancing prosthetic to compete? There's a lot of possibilities that we have to kind of look at. So in conclusion, I talked about prosthetics today, how near-infrared spectroscopy and optogenetics can be used to enhance prosthetics in the future, along with machine learning. I talked about how these could potentially lead to enhancements on the human body. And I discussed whether these prosthetics enhancements are ethical, considering the issues of disparity in sports. And if they keep advancing, one day we might have prosthetics like the ones in like Star Wars and stuff. So yeah, are there any questions?
So any questions?
Which, the long jumper, which leg did he jump, did he leap from, do you know?
I don't know. I didn't look that deep into it. But
Seems to me, like if you're jumping off your regular foot, but if you're jumping off the blade.
yeah, maybe just because of the run up, you know, they might be thinking that it's better for that. But I don't know, yeah, it's weird.
You know Pistorius is in jail.
Yeah, I do. I was not gonna lie, I was kind of considering if I want to talk about him on my presentation, but he was also a big part of, you know, that thing, so I still put him in there.
Why is he in jail?
He killed his girlfriend.
Killed his
Really?
girlfriend, shot her through
the
the
bathroom
door. Claimed that he thought she was an intruder, but it doesn't seem very likely.
Yeah.
But the reason that you asked this, you see, this is one of the most famous sports figures, right? So it's a very interesting part of modern society that it's so dysphoric to listen to the news that most famous people don't do it and most young people don't do it. So the reason you don't know about this, you would have known about this in a previous era, because like every hour you would listen to the news during the day, right? But, and you can't really be criticized, because you'll find that the most famous people never listen to the news. They maybe assign somebody else to listen, and occasionally will tell them that something surfaces that they think the boss should know. But anyway, so for you not to know this is common today. But in a previous era, if you were interested in sports, there was no possibility that you wouldn't know about this. Yeah, so it's one way that society has changed.
Yeah, I only found out while I was looking him up to like find out about the sports stuff, and then I saw all that. Wasn't too sure what I should include it, but
Yeah.
lots of really interesting stuff. You know, it's obvious that that for therapies, you know, for amputees, you know, this is miraculous technology. You know, when you talk about, and I buy it, the idea that we'll be able to use our minds to move things fairly soon. I agree that it has incredible implications for things like surgery and whatnot. You know, but then so the question of distribution is interesting. You know, it's almost, I mean, it's just a fact that you can't give everybody in the world stuff that's new. I mean, it's, you know, as things start as a single idea, you know, they're only going to be available to a limited number of people. So I think it's a good question of, you know, how much should, you know, injustice or the inability to share amongst everyone, you know, stop a certain group from plowing forward. You know, so that, I mean, the idea that if you can't bring enough to share with the whole group, then don't bring it at all. At the same time, I think that human progress, you know, sort of depends on this vanguard, people that are going to, you know, take the risks of being the first ones, and it's almost by definition it can't be fair.
So, you know, there's something that we don't think about very often, but if you step back and think of the really big picture, the decision to stay biological as opposed to, you know, uploading our consciousness to a ceramic slab or something, will depend upon a lot of these things. How frustrating is, you know, biology in 50, 100 years from now? How unequal is it between people? How many people are upset with their own, you know, biology and jealous of other people? And then when it becomes more and more possible to take the non-biological route, if we make the wrong ethical decisions, people are really going to want that, because having a body totally sucks. Whereas if we do things right, and, you know, this course can be, in a minor sort of way, part of the, you know, determination, shifting that balance a little bit. If we do things right, then we can keep bodies for thousands of years, and, you know, it's much more desirable. Because if you think of the psychiatric side effects of suddenly finding yourself in a ceramic slab, they're very, very considerable, right? I mean, when you wake up in the morning and think that you want to go to the window and look at the sun, and you think, oh, I'm a ceramic slab, things apply, right? So, yeah, I think
you won't need to go to the window to see outside, though.
No.
Access any one of the million cameras.
Yes, that's right, yeah. Okay, other questions? Okay, thank you very much. I'll go on to the third presentation.